Hello everyone, good evening and welcome to KNVTS Amsterdam's first webinar of 2022. Happy New Year, I guess. And well, we had our hopes that the situation would be a bit different right now, but it is what it is. So for now, I'm Mariana Candela. I'm a board member of KNVTS Amsterdam, and I will be your host for this evening. For those who don't know us, KNVTS is the Royal Dutch Association for Maritime Engineers. You can learn a bit more about us in our website, knvts.nl, where you can also check out lecture schedules for all the branches and get your membership and more. You can also follow us on all social media, LinkedIn, Facebook, or sign up to our newsletter. But now let's go to the real reason why we're here tonight. We have a super interesting lecture for you with our own Ton Bos. Ton, besides being the president of KNVTS, he's the director of hydrographic and marine consultants, better known as HMC. He has over 35 years of experience, and he started as an apprentice at Weissmuller Group, I guess, the predecessor of Dockwise. We are really lucky to have Ton here tonight with us, because one of his passions in life is to teach. So I guess this will be a really good lecture. And well, I thank you in advance, Ton, and everyone enjoy the lecture.
Thank you, Mariana. Do you hear me loud and clear?
Yes.
Thank you for your introduction. I switch to my screen then. Can you see the first page? I hope so.
Yes, we can see everything.
Okay, thank you. Gave it the name the Art of Transport Engineering, and I will tell something about the history, how we started, what we learned, and items to look at. Of course, I have half an hour about that. I cannot explain everything, but I try to summarize what we came across, and hope to get some new information towards you. I will talk about the history. After that, I will talk about the various ship types and the developments from start to the ships we have now. Important for transportation engineering is the sea behavior. I will touch a few items there. And of course, structural integrity is an important thing. Then a few items about the stability book. Often the stability book of heavy lift ships are, let's say, based on merchant marine ships, but basically those heavy lift ships really have some different issues. Then we will talk about the 2010 rule, the start of making the manuals. The start, it was already in the 50s, developed this rule. But we still use it. Now it's called default motions. And then I will then finish off with some examples. I show you a little bit of the of a very old movie, one of the first ones.
Mention Holland, and what picture does your mind conjure up? A land of windmills and wooden shoes. A land of polders and dikes. But wait, what's this? A ship? Part of a ship? Perhaps it's half a ship. If you haven't guessed by now, Behind that dike is a very unusual type of ship. Conceived in Holland, born in Japan, and now in demand all over the world. Here we have the end of this remarkable ship, but the beginning of our story.
In 1983, Daewoo Shipbuilding and Heavy Machinery Limited, whose yard in Okpo Bay on Koji Island, South Korea, is well known for constructing large industrial plants, completed 28 modules destined for a petrochemical plant in Al Jubail, Saudi Arabia. The modules were designed by the contractor Fluor of Irvine in California. Stability calculations were checked and rechecked.
Jan, I think the next item on our agenda is your...
At a very early stage, too, meetings were held to discuss all aspects involved in the project.
Well, actually, it's working very simple.
Weissmuller could use a very simple loading and discharging ramp because of Super Servant's excellent ballasting capabilities.
Very simple.
Superintendent Jan Arnoudse explains to Kent Goodman of Fluor how this ramp will work.
You have the key, the fender, and the ship. Because of the small gap and the possibility, because of our good ballasting system, to stay level with the key, we only need 25mm ram plates, which will be connected to the ship by small steel straps welded to the plates and to the ship.
Onto the deck, the transporter can be driven off without delay. Module number 4 is brought aboard.
This was a small film about the first self-propelled heavy lift vessels, submersible heavy lift vessels, developed in the engineering departments of Weissmuller Group. But let's say the history even goes back much longer, and that is when we used in the 1600s the so-called sea camels in Amsterdam, where the big sailing vessel arrived, waiting to enter the port of Amsterdam, and they used the so-called sea camels, where like a kind of dry dock connected around the sailing boats, and then deballasted, and then it could be rowed into Amsterdam and thereafter discharged. That's the reason why ITC from Haarlem developed the so-called bottom reaction barges, and that generation was also called the sea camels. Bottom reaction barges are barges that are afloat, then submerged by ballasting in the stern, and it got the stability while resting with the stern on the seabed. Then you bring the cargo above it, and you start to deballast again. And the stability is you got from the waterline in the front and the waterline of the cargo, and then you pick up everything. And the picture shows you an example of a ship unloader being loaded in this manner. Let's say that's the real first generation of semi-submersible barges, but they always had to be towed. Then after that, in IJmuiden, we designed the ocean servants. These are barges which had a small propulsion to assist the tug, but they always had to be towed over large distances. And in the front, you have a big ramp where you could beach the vessel and roll off all kind of cargo. Special feature in this case was that it had a stern casings, two bow casings, And that makes it possible to submerge it horizontally, irrespective of the water depth. And that gives a lot of flexibility. After the ocean servants, we developed then the super servants, the self-propelled versions, and the ship types, the dry transport carriers developed after that was, let's say, the open stern. Those are the ships you can reach from 3 sides with the bow and with the bridge on the bow. Then we had, there are only, as far as I know, 4 build of tankers. They were used as product tankers when they are not in heavy lift mode. And if they are in heavy lift mode, then the tanks would be cleaned and could be carried heavy cargoes. Next to that, we have the converted tankers and bulk carriers. Those ships were converted to heavy lift ships, and there are still vessels sailing, like the T class of Dockwise is still used as converted tankers. And the 4th type is the dock type, multi-purpose type of ship. This is the general arrangement of the super servants. When you submerge, you get your stability from the waterline area at the bow and the 2 casings at the aft. Those vessels are still operational. The Super Servant 4 is still transporting yachts. The Super Servant 1 is also not demolished yet. It is a rock dumping vessel. So those vessels still have a function in the world. After that, we came with the new design, Mighty Servants, the larger generation. And the thing behind this whole design, I show you on the next page, is that for carrying light cargo, you have a U shape of hull. And that means that you don't need all the dead weight nor the stability, and you had a gentle motion. And for heavy lift and real heavy cargoes like gorilla type of rigs or semi-subs, you could carry them, and then you have the wide waterline with a lot of stability. What we didn't really realize is that this sponsoon type gives a lot of extra damping in your motions, and your motions increase quite a lot, and you have a lot of turbulence, and also in choppy seas you have a lot of fatigue. That was the design flaw, but nonetheless these ships were copied in the Far East, and they are still operating with those kind of sponsoons. The Mighty Servants, however, Mighty Servant 1 is widened and brought back to the U-shape main section. The Mighty Servant 2 unfortunately was sank in Indonesia, and only the Mighty Servant 3 is still operational in this shape. Another type of heavy lift ship is the unmanned barges. This is the example of the Gavea lifter, operated by Fairmount in those days. That was the highest capacity barge with 50,000 tons of dead weight, and we did a lot of work with them with that barge using the tugs from the Fairmount fleet, and in this case we brought 2 big rigs from the US Gulf to the Arabian Gulf. Underwriters are not very happy with the towing. That was also the reason that the self-propelled ships were very popular. In this example, you see the Ocean Orc loaded with a big rig, and basically only these kind of operations are feasible because you can use the uplift from the cargo, and that contributes to your stability and your stability area. So basically, for every transport, you have to prepare a transportation manual, which in fact replaces the stability book in that sense. This was also a very nice adventure for myself. It was the CB Venture. It was a converted tanker operated by ITC, and I was sent out by the big competitor Weissmuller to see how this loading operation, it was the first one in Quebec, how that was done and if that was successful. And here you see also that we were very prudent in the operations, like in this case the jackup legs were cut because that we were expecting too high motions, and the legs were cut and then placed on deck. In the first beginning, we used the rule of the thumb, the 2010 rule, and later on we used motion responses based on RAUs, because in those days you had not reliable motion response programs, but it appeared that the motions were much better for these kind of hulls and these kind of ships, and we could load jackup rigs with the legs still installed. And as far as I remember, the highest leg we had on the deck of the Super Servant was 135 meters, and even on one of the bigger semi-submersibles it went up to 205 meters leg length, and of course that was a real improvement in the transport using the motion response calculations. But nonetheless, what you see, I make a comparison between multi-purpose ships versus module carrier. The so-called module carrier were not submersible, but they were built to carry as much as possible modules. There are a lot of modules being transported, especially with the building of all kinds of LNG trains in Australia and in Russia. The idea is from these ships is that they have a small depth, a large beam, and a short length, so they could handle a lot of modules. And the small depth is necessary because you should be able to enter in all kinds of ports and come alongside various key sites imports. The disadvantage of these ships with an L over B is that they have a very stiff sea behavior and high accelerations. In this calculation, for a significant wave height of 4.4 meters, you can see that the multi-purpose vessel has a roll acceleration of a little less than 9 degrees per square second, and the heavy lift vessel is about 6 to 7 times higher with a high accelerations. And those ships with an L over B of 3 come very close to, let's say, the rule of the thumb of the default motions. So I always prefer to do as much as possible motion response calculations, but sometimes we fall back on the default motions. Here is another type of transport which we did last year, not last year, but the year before. Transportation of cascos, inland hull cascos on a bulk carrier. It appears that the motion responses were quite okay. In this vessel, we did it in concert with NEPA. We could monitor the motions and follow the ship every day, and those data are still being analyzed. Here you see that the vessel entered Rotterdam safely. What happened here is 2 years ago, the client is used normally to transport bulk cargo, and they gave us accelerations, especially the roll motion of 6.08 meter per square second. Also, calculations were done by IMO class. They came up with, but if you you choose the default the rules of the DNV, which were based on the Noble-Nanton rules. Basically, you're not allowed to use IMO calculations. You can only use that for loads up to 100 tons. When you do motion and response analysis, in this case diffraction theory, we came up with 5.2 meters per square second. But since the vessel was equipped with the double engine room, you can apply heading control. That means that you can reduce your significant wave height by 60%, and then you come with a motion of 3.44 meters per square second. As I said, we also measured it, and the whole trip we had a transverse acceleration, combined acceleration of 2.6 instead of the calculated 6.08. And according to our measurements, the roll angle we had during this period were 15 degrees. So it's quite a lot. Here you see in an histogram the various calculations, whereby you can see that motions with heading control are much lower, and they come close to the measured values. As I said, we are still analyzing these kind of data and try to develop. We have done some measurements on other ships as well. We try to develop a safety system for on board the ship. Next to that, we do work together closely with the company called Hermes, and they provide every day, every 3 hours a wave, let's say in environmental conditions, with a good overview of the waves and environmental conditions over a large area. In this case, you can see with this arrow, this is the position of the ship, and we just missed the extreme weather while crossing the Gulf of Biscay. For instance, an example of the Poseidana, we had some problems around the Philippines, Cape of Good Hope and Lisbon, and we were in close contact with the captain to direct the vessel safely to Rotterdam. And here you see the wave periods. This vessel had a natural frequency close to 15 seconds, and we try to avoid that. It comes into weather with encountering waves, beam seas of 15 seconds. We are now working on integrating this environmental condition with motion responses and to prepare a very good safety system to inform the crew basically more or less continuously. Another issue at these kind of vessels is the structural integrity. The module carriers with the small depth, I always said it looks like a chocolate bar, and you put a lot of concentrated loads on the deck, so structural integrity is a big issue. So what we do is to model the ship in a finite element situation and look at the deflection and the hogging and the sagging. Why is this so important? If you see in this example, you have a big module in the center of the vessel, so you have quite a high loads in the center, whereas the homogeneous uplift is well distributed. So you see that the ship has to have a very strong construction, especially also in the middle. If you compare it with, let's say, a merchant marine vessel, a container vessel, where the load is quite nicely distributed over the ship, and the uplift is also very well distributed, so the cross section can be built less heavy. Another thing what you see often in those stability books, this is an example of a special ship that is discharging cable over the stern, and in this, for instance, a particular stability book, you see that the bending moments are going to zero, and frankly speaking, you're not allowed to put any loads at the stern. So we often have to adjust this part of the design, the deck load diagram, to calculate how much you can have here on the stern when you load cargo, or in this case you have cable over the stern. So you see that in those stability books designed by regular design companies, that they sometimes miss these kind of things. Or in cases of submersible ships, they just put a block on the ship as a load, whereas it should be more. We made often addendums with jack-up rigs or special carrying modules to show that the vessel is capable of doing this kind of transportation. An example how it started with the 2010 rule. These were the small manual pages we used for the 2010 rule. 2010 stands for 20 degrees of roll in 10 seconds. And these motions are still applied using the DNV default motions. It's a little bit more refined, but still often used, and especially with those module carriers, the loads derived from these 2010 rule is not far off from motion response calculations. This was the pitch rule, and that's 12.5 degrees in 10 seconds. Here you see a picture showing the development. The Super Servant, the first heavy lift vessel I was involved in, was a dead weight of 11,000 tons. And nowadays we are talking about, for instance, the Vanguard of Dockwise with 111,000 tons of dead weight. So it's quite a growth with all kind of challenges. And we're developing our safety system for these kind of ships in order to reduce the risk at sea. Of course, risk zero will never be possible, but we at least try to achieve a very safe operation. Some examples of dry transport. This is a spar buoy. I told before that the stability is gained by the cargo itself, and these round systems, must say you have a relative small waterline area, and especially the loading and discharge operation are very critical for these kind of cargoes. Another thing like jacking of, let's say, skidding operations. Barges have to have a very robust ballast system. When these big steel constructions are pushed on the deck of the ship, and what I experience is that ballast systems most of the time only consist of a ballast ring, and that is not always easy to cope with all the rules and regulations for loading these kind of cargoes by means of skidding. Especially skidding, taking about 14, 15 hours. You have to keep up with tide, so that that is always a challenging operation to determine and calculate a very good ballast system for this type of operations. Another example is loading a jack-up rig by means of jacking down. This was done in 2008, where we have the heavy lift vessel Fjord loaded with a big jack-up rig at the stern, and the challenges were that all load of the rig was on the stern, and we had to take into account the draft restriction at the bow. The vessel was not allowed to sail with less draft forward of 5 meters, and to avoid all kind of slamming. Loading was done in Kirkenes in winter time, so we crossed the nice Northern Sea and Gulf of Biscay during winter, but we managed to work this all out. Here you see the loading operation in Kirkenes, where it was a temperature of -37. Here you can see a good overview that the vessel was carrying the rig on the stern, and to get a little bit of uplift, we had the sponsoons of the rig in the water to achieve some more uplift and reduce the bending moment in this case. This is off Malta, where she was discharged with a jack down operation again, so it all went safely, and it was a safe operation. In transportation engineering, towing is something special. I don't address much on these kind of subjects, but this is an overview of 4 pictures with several challenges. This picture shows you a double tow with the 2 tugs in front of it, done regularly in the Far East. This is the towing of an inland barge from Rotterdam to Nigeria, with all kind of challenges. Here we have a large FPSO, and in this case towed by 3 tugs. The challenge here was that if the middle tug has a blackout, how much time do we have to take measures to avoid an overrun by the FPSO, because when towing, this heavy construction still has speed, forward speed, and the heavy tow wire will drag the tug afterward. And you have, in this case, only 6 minutes to make the safety measures. Another example of very complex types of towing is this gravity-based structure, where 6 tugs is bringing this construction on the place, and especially with these kind of powerful tugs, you cannot use a very short tow wire because of the wash of the propeller. You will push yourself rather aft than forward. So these are all kind of engineering challenges. I had the opportunity to do this for about 40 years, and developed kind of courses on all these kind of subjects. This is about the short story in 30 minutes, the history of transportation engineering and some of the key issues. I'd like to thank you for your attention, and if you have any questions, please send them. That was about my story.
Thank you, Ton. Well, we have a couple of questions coming in here. I'll read them for you. First, Robert Stryland asks if you can tell us anything about offshore discharging, if there are any new ideas about this complex issue with the present heavy lift cargoes.
Yeah, that is indeed a big issue, that you have the damping between the cargo and the carrying vessel. I must say, and admit, I have looked at that subject a couple of years ago, but we have no real, let's say, safety issues at this moment. that's still an challenge to see what is the motion behavior of the two independent floating objects. So no, that is still a challenge.
And Ton,
and
one question.
Especially with this big heavy things, the offshore pits are not available enough to do these kind of operations in protected areas.
One question from me, actually. What type of software do you use? Do you develop software for it? Is it code? Is it commercial software? You don't need to advertise for anyone, but
Oh, let's say we started in the early days with the ShipMo, which was developed by Marin. That was the so-called tuned version. They developed for Dockwise 20 odd years ago. We use SafeTrans, which is developed, which the development started in 1996 by 31 companies. And I must say, I think in 2005, this system became operational, which we often use. And basically, at this very moment, we are still checking which calculation is the best one to do. The problem with all standard systems is that they only take into account the underwater part of the hull and not things like overhang or sponsoons. So that's why we also do a lot of motion monitoring and see if we can tune those calculations. I always say here in the office, like some of those nice programs, they are very good in the look and feel of 2022, but the technique is insufficient for these kind of complex towing operations. So SafeTrans and ShipMo, in my opinion, the tuned versions are still one of the best. And of course then CFD, although CFD has problems when you have to use it in both water and air at the same time.
All right. So Martin van Dijk asks, how high are the insurance costs for the cargo? Is seaway is the main issue or the cargo?
Do I understand that? Let's say in terms of insurance cost, we are still having more or less the same rates. But I do not really understand the question in the sense, let's say the insurance is always related to the cargo. That's the value of the cargo.
But I guess what Martin is asking is if the insurance cost changes depending on where you're going through. For example, if you're sailing through the North Sea where you have harsher environments, is it more costly than if you're sailing, I don't know, in more enclosed areas in the Mediterranean or something?
No, basically they charge you on the basis of number of loading and discharge operations, rather than the area you are let's say transporting the unit. And there is a big difference between towing and semi-submersible dry towing. Let's say the value of the insurance premium for dry towing is about 0.25% of the value of the cargo, and for towing you are let's say 5 times higher.
And how would you choose between one and the other? How would you choose? Is it the size of the cargo alone, or?
Now, most people prefer the dry tow. So without a tow wire, the only thing is that in very, very big cargoes, you have no choice, and then you should tow it. Although I must say the Vanguard was developed to carry also FPSOs, which they did. So they make the market bigger for heavy lift transport, and a little bit more difficult for tugs.
Okay, but is it cost effective to carry it instead of towing it?
Yeah, let's say three big tugboats is also an expensive exercise, and
Yeah.
especially when you have an example of 3 tugs. We had a lot of discussions with some oil companies that they don't like the 3 tugs because there has been one accident when the center tug failed and it was run over by the FPSO, and that people don't like so much.
Yeah.
But recently, ALP delivered an FPSO using the 3 tugs, so apparently they could convince the oil company to do that. But then you're talking about the 300-ton bullet pool tugs, and I don't think that can be handled by a heavy lift ship at the moment.
Mm. And let's talk about fun stuff now. How does it work with yachts? How is it different, and how is it carried?
With yachts?
Yeah.
Yeah, that's becoming very popular, the transport of yachts. Basically, you have the same issues as we have here. The only thing it's private owned, so people are very sensitive about the possibilities of damage. But yeah, basically you have the same issues. The only thing is, I think in sea fastening we can still improve to safely transport yachts. Let's say in the business we are in, we don't like lashings and chains. And in yacht, you see sometimes a complete, I always say, a piano with all kind of steel wires. Whereas that is, in my opinion, a difficult issue to get all the wires at the same stresses. So I think there is still some work to do to invent better sea fastening possibility.
Is there any regulation on that? You were talking about regulation that I guess is more for larger cargos. Is there any regulation?
The cargos same. It's the same.
Oh, the same. Okay. All right. And I also have here a question about, well, you were talking about integrating the weather forecast with motion analysis. How is it going to happen, the communication with the crew, and what are you providing? What to tell the crew, and how can they change their course, or what can they do to avoid any trouble?
Yeah, we are about to deliver a system for a huge yacht where we have a polar diagram indicating what kind of speeds are still safe enough for sailing, and especially related to the strength in the hull. The vessel has sensors. We place sensors on the hotspots of the hull to monitor the strengths while they are sailing, and then the information to the ship is if the accumulated fatigue damage is increasing, and also if the motions are too high and the waves are too high for the operation, compared to the results of the polar diagram showing what kind of speed is still safe in the combination of wave height, wave period, and wave direction. And the environmental conditions is like what I showed you in the other picture. You have an overview of the area and gives you good idea about what kind of waves you are going to expect in the next 3 hours. And that gives then the information that you can expect that you are entering in environmental conditions that is dangerous for the vessel and its crew. That's let's say the first version of our what we call safe plan. We have integrated motions, weather, and response of the vessel. And this, we still have a couple of years to go to make it to improve it. We got some subsidy from the European community to further develop this in the coming 3 years.
Very good.
But I think the prototype is already there and will be commissioned in, let's say, in a month from now and tested.
All right, good. Keep us posted.
Definitely will.
And I think one last question. What would you say is the busiest type of well, not busiest, but what is the most poignant problem in this section of the industry right now?
I want to say
what are you most busy with these days?
Yeah, I think it's awareness of the perils of the sea and let's say how to prepare this kind of operations. And I hope I still have a couple of years to transfer my knowledge to people around me, because I see that many multi-purpose ships are being used for project cargo, and I think the awareness is insufficient for safe operations at this moment. So we still have a lot to do. In the past, you only have a few heavy lift ships, but now everybody is entering in special transport because there is more money to earn, and that is giving some challenges to improve the safety. So we still have a lot to do. Creating awareness.
Okay. Well, very good then. Thank you, Ton. I guess if no one else has any more questions, let's stay here now. Let's go now. That's it, I guess. Ton, anything else you'd like to say?
No, I think I make a point. So thank you for giving me the opportunity to spread this kind of news.
Yeah, well, thank you. Thank you very much for your time, for the presentation. I really, really enjoyed it. I hope everyone else enjoyed it as well. I don't think we need to give you a complimentary KNVTS membership, do we?
No. I'm enough involved.
Yeah. I'd also like to thank Thijs as well, as always, for the background support. Again, for everyone else, if you'd like to know more about our events, our live events that hopefully we'll be able to do again soon, and our webinars that we are not foreseeing stopping, please sign up to our newsletter. Our next webinar will be in February 16th. It will be about the Moray base, floating wind foundation designed by the company Maridea to be mass produced. So pretty interesting as well. I hope to see you all there. Thank you for your company tonight. And tot ziens, I guess. Bye.
Peace.